Welcome everyone to today's Performance Clinic. Why Devs Love Dynatrace final episode. Season finale.
Episode 4.
Exactly. Runtime Optimization. It was like 2 months now where we've been doing this, or where you've been doing this. Initially, this was a hot day, a hands-on training day, 4 hours.
Exactly.
And then we said, let's get this to the people via YouTube and let's break it up into individual episodes.
Exactly. Yeah. Exactly. So much content that we decided, hey, instead of one episode, let's do a webinar and show you what is possible. And this is just like the tip of the iceberg, guys.
Yeah. And there's more coming because there's new features in Dynatrace.
Yes.
I just said, we should show the
And they were like, what? We have to show this. And it's like, we don't have time. We have so much content. Yeah.
Okay, without further ado, folks that are live, if you have questions, please put it into the Q&A feature because it's easier for me to moderate. And if you have questions later on, if you watch this, you'll find our names, you know how to get in touch with us, or post a question on community.dynatrace.com. But with this, Sergio, the floor is yours.
Thank you.
Take it away.
Hi, guys. So today is episode 4. If you have followed us, we have been doing episode 1, 2, and 3 of Why Devs Love Dynatrace. Today, we're going to talk about runtime optimization. So a quick recap. Episode 1 is like trace diagnostics, giving developers feedback, good quality feedback. Episode 2, we introduced intelligent quality gates. Episode 3, we were comparing releases, different releases, overlaying one with the other. Really, really cool features there. And we saw and identified problems to code. And episode 4 is runtime optimization. That's what we're going to do today, right? So before we start, everything is out there public for you to test it out. We have set up a Codelab in Dynatrace -perfctlinux.github.io. Also in here, you're going to find a lot of open source initiatives that Dynatrace is starting, like Monaco, for example, that we have out there. So you can configure everything with GitOps approach. This Codelab is made also with a GitOps approach. So you can spin your environment, your endless CI/CD pipeline with Alfred, which is the monkey doing problems or simulating problems. So give it a try. And today, don't have. And it's gonna put the. I know it's actually after the. I think I have the slide after the
credentials, you mean?
Yeah, exactly.
Yeah, they're coming.
So I can follow along.
Yeah, I will try to put all the links that you have on there into the chat window when it makes sense to share information. Yeah,
exactly.
Yeah.
Okay, so let's just do a small recap what we have seen, and we can start with the hands-on. Episode 1 was about distributed trace diagnostics. So developer get feedback right away from staging or development environments, right? With Andy and myself have been presenting this. We show the value of the one agent, the full stack. And today we're going to recap on the full stack because it's not about the metrics, it's the traces, the full stack, the whole entity model that we can navigate through it. And we're going to do it today. Features for developers, the PurePaths 4, and we show all the features and the diagnostic tools because it's not only the quality of the traces, but it's also how to analyze, right? How to analyze thousands or millions of traces with all this different information, right? Then we show some best practices, some dashboards so we can analyze big environments, the diagnostic tools. We play the role of a developer, right? Getting the feedback and we start testing. We play the role of a tester with easy trouble, right? Sending a REST call and finding these traces with the SQLs and all the distribution automatically, right? Nothing was configured, but the HTTP header for the developer name, right? We saw the SQLs, the fetch, the rows, everything automatically. In episode 2, we said like, hey, let's level this up. And we create synthetic test, REST synthetic test and browser test. Then we introduce the intelligent quality gates, defining SLI, SLO, so you can evaluate all your applications with one quality gate, right? Like all the services of your application. So the idea is that you can level up your quality gates. You can level up your pipeline. So whatever you're using, if you're using Jenkins, Azure DevOps, GitLab, any deployment or even shell scripting that you're using, you can make it even smarter with the cloud automation quality gates, right? So we show you, for example, in here, you can see 5 deployments are failing and 1 is not. This is because we have a timer every hour and 5 problems. Dynatrace has no idea about it. Cloud Automation has have no idea that they're bad, right? And we see that they fail, okay? So we saw the integration with the load test and the architecture diagram of the quality gate, right? And in episode 3, we were showing the captain performance, why the release failed. Because one thing is to know, okay, it failed, we know it's slow, but why is it really slow? Why is it really failing, right? So we start comparing and seeing down to the code level why something was failing. In one case, we saw that we had thread issues, right? And Dynatrace is pinpointing that one release has a database increase and log increase, right? Same software, same load test, different release, and we can pinpoint exactly to the code level, right? We even decompiled some code and saw the bad implementation of the other release, right? So, yeah.
Very cool. So I also posted the link again in the chat. Mm-hmm. So folks, in case you have missed the first 3 episodes where you walk through all these cool things,
exactly,
just go to the GitLab, to the GitHub page that we just posted in the chat. And I think if you're coming in late, I keep reposting it because I think if people join late, they may not see all the chat history. Yeah,
definitely.
Yeah.
So yeah, and all the videos, all the episodes are 1-hour videos, and we have it linked at the beginning of each Codelab, right? So you can follow along. Mm-hmm. So, and with this, we're going to kick it off. Runtime optimization. So now it's about not only comparing, but let's say you have one release, how to optimize this release, right? How to see that you have a memory issue or a synchronization issue. So instead of having 2 dimensions, we're going to have 1 dimension or only one release, but analyze it from bottom to the top or top to the bottom, right? So as the other time, thank you for being here. So we have a user for you. It's called Dynatrace Lab, and the password is very much. The tenant, if you go to this server, to this URL, you're going to be directed to the webinar environment where we're going to do the hands-on today. So we're going to start with memory allocation. Before we do the hands-on, I just want to explain a little bit theory, what the issue can be of memory allocation, right? So we have, again, captain performance, and we're asking him the question, hey, which release has a high garbage collection impact, a memory allocation problem, right? So we should identify the process, the API. With API, I mean the package. Is it a third party, a first party, or some other software that we have in there in the application? Which service is it? Which objects and classes are affecting? Why is it this? And is it a specific test step, a specific request that is the one that is slow, right? Before I jump, just small information about how the JVM works, the Java memory. So we have the Java memory, the virtual machine creates objects, right? So when an object is created, it's gonna first go to the junk generation, right? And we have this hidden space. So, and the objects in a memory have a specific time to live, right? So when the JVM, when the object lives for a long time and is not used anymore, the JVM tries to clean these objects, right? So like, hey, I want to clean up because this is like garbage and I don't need it anymore. What we need to know is that this cleaning up process is called suspension time. It's the garbage collection, right? And suspension time means that all the process in my JVM are going to be stopped, right? So for the small cleaning is normally not an issue. That's a normal cleaning process. But if you have a software problem that you're not using the JVM properly, you're creating a lot of objects, or you're referencing something and you forget that reference, it's going to start to increase and sometimes even explode. We call it out of memory exceptions, right? So, and this can, in fact, not only the transactions using those objects, but also all other transactions into JVM. Very important to know that. And Dynatrace is, even if the JVM stops, Dynatrace, the one agent, is able to tell you for how much time it's been stopped, which transactions, and what is the impact overall of that time, right? So it's very important to know that. I'm not gonna go into details. Very important is to know that the suspension time on garbage collection is important for you to have in your software in confined, right? And today we're gonna figure out the problem of it. Now, Dynatrace has also something called API detection rules. So you as developer can define your rules, like the front end, the back end, anything in your software, and everywhere in all your environment automatically with charts, you can see the usage of the transaction and the software, the memory of the bytes allocated in specific packages. Really, really cool, right? So in our case, we're defining an API for easy travel and another for the Derby database, right? Because the application that you spin or that we are using is using just a Derby database, right? Which is a Java JVM. So let's start with the memory allocation issue. Right. So in here we have our performance dashboard, right? So a nice way to see the memory, for example, we have here on the bottom, the process memory allocation bytes per API, right? So if I click in here, and I will show for the like 6 days, because we have 6 releases, right? I'm seeing the load test, right? At the beginning of the hour, at 12 and at 6, with the API usage. So in this one, we see a lot in easy travel, which is the blue one. And in here, we see a lot of the Derby database, right? And this is overall. So on the right side, here we can use the management zones, right? For example, let's say you have different staging, different applications. We're interested in easy travel. By clicking on easy travel, now I'm filtering only on the easy travel processes. Really, really cool. So, but I also want to understand which processes. I might have hundreds of processes or processes that are not interested for me. Interesting. So I click on the process and I add the dimension of the process. So I can see now that on the left side is the Derby database. So I'm not really interested here because this is just, this is another issue. I'm interested in easy travel, right? Which is this process. And we see is the business backend jar, right? So in Dynatrace, we don't only have metrics, we can also click in them and say like, okay, let's go to this process. So now we navigate to the process, right? We can see the automatic tagging, the services, the process metrics, right? And we can see here the CPU and even the deployments, right? So if we go to the JVM, there we go. Remember the dashboard that we have by the APIs in here at 4 p.m. We see the deployment DB spamming out makes a huge suspension time increase, and also the garbage collection is increasing really high.
Hey, Sergio, quickly, as a reminder, folks, I have posted the link to the environment that you share here, the GAB265 dynatracemanage.com. Also, user is Dynatrace love, password is very much. So awesome that you're sharing this environment with the people that are live so that you can also explore it. Another thing I want to highlight here, these markers, these deployment markers, this is simple yet so powerful. Folks, if you are deploying or doing things in an automated way, where you run a test, where you deploy a new version, where you change feature flags, you can use the event API of Dynatrace to send deployment events to Dynatrace. You can send it to any type of entity, but sending it, for instance, to the process group or to the service, they will then show up in the different charts.
And automatically. And here, for example, we see the event in the chart, so we can understand that at this time, hey, look, deployment, we have a deployment in here and an increase, right? So on this side, we have also the event of that deployment linking all the systems, the application, the configuration service, the pipeline, the Jenkins running behind it that we deployed, right? So everything is in there. We're tagging all the systems and all our release and our pipeline, right? So we can automatically even see, hey, who approved this? Oh, it's Sergio. Why did you approve
Sergio
it?
again.
So very important. And this integration is in episode 2, guys.
Yeah, so check it out. Check out the previous episodes. Also, if you have questions, please use the Q&A feature. I'm moderating here. So that I'm not just sitting around and doing nothing. I try to moderate the next question.
So what are we going to do now? Since we're interested in the memory, you have a button here called Analyze Suspension, right? On the process that we already identified, which is the backend. I'm like, okay, let's click in there. So what we're opening now is called a memory profiling. So Dynatrace is able to do a profiling continuously of your processes. Really, really cool feature, which means that it's able to show you the objects that are growing and the amount of memory that is allocated to those objects, right? So here we have all allocations or survivors, and we're interested in the survivors. Remember those that the JVM cannot clean and it's tried to clean and it's not. If this happens for a long time, the application can explode, right? Or the pods. A lot of people think like, oh, Kubernetes is gonna fix it. Well, the pod is just restarting and restarting and restarting.
And you get all of this information fully automatically, just the one agent monitoring your Java processes, you automatically get all this information. That's awesome for developers, great for performance engineers that are hunting memory leaks, that are trying to optimize memory behavior.
Exactly. Which, by the way, we can trigger memory dumps from here, right? But this is a feature that maybe for another webinar,
it's just making sure you have more content to come back.
But now we are like, let's say this is a more in a running environment, right? So, okay, we see here 31 gigabytes, right, from the JPA database controller. And in those bytes, at the beginning, I will say, well, it's a byte array. But where is it? And the beauty is that we can see the hierarchy. So from the byte array, we have 7 gigabytes, but we also have an entity, managed entity implementation. And then the next line, you see that JPA business user, right? So it's user data coming from Hibernate, right? That is the one that is on the memory of the JVM, right? So it took me 2 clicks to understand what is the impact, how many objects are growing, right? Survive objects, 800 million, right? And the classes in there, right? So
that means, just to recap, if you're looking for ways to figure out what's the code that is consuming most of your memory, that doesn't get cleaned up, you're constantly running out of memory, then this is just a great way to say which objects survive garbage collection, right? How many objects, who is allocating it? I mean, it's just amazing here.
Yeah, really cool. I'm going to be switching this between the slides and the live. So you see that it's not only PowerPoint presentation, but these slides are showing you step-by-step later in the Codelab so that you can follow, right? So that we have shown, right? The object, the amount of objects and the classes. So now, since it is Hibernate, this is SQL. So let's take a look at the SQLs, right? That are coming at 4. So we have our performance dashboard, which this was changed.
And by the way, people have asked me after the previous performance clinics, these dashboards, if they can get them. Of course, it's all part.
Everything is in Monaco.
Everything is Monaco. Monaco stands for monitoring as code. So the whole Codelab that Sergio built is automatically setting this up also in your environment. That means all the dashboards, everything, just take it, launch it, and you have the same dashboards in your environment.
Definitely. So now we're gonna do, we'll go here to the top database statements, right? To see at that time, and we see already at 4 amount of statements, right? So, but since we know that there is an increase in the JVM, that means we're fetching information, right? So let's filter not by the amount of requests, but by fetch count, right?
So we do have a metric on how many rows have been fetched when we execute
automatically by every. So we automatically, or the Dynatrace one agent automatically is recording the SQLs, the time, the amount of fetch and row count.
That's also interesting because the fetch and the row count is interesting because fetching is typically fetching a bulk of data.
Exactly.
So you can also figure out bulk sizes like fetch sizes.
Exactly.
If you may have a misconfiguration.
Exactly. So in here, and that's exactly what we're gonna do. So we have a request count of almost 2,000 with a fetch count of 900 and of row count. Where do we have the row count? Here we have it, right? A row count of almost 10,000, right? So, and if I go to my slides, we are noticing that each request is delivering around 10,000 rows by 1,000 fetches, meaning we just make a small multiplication and we get 20 million, roundabout million user data that we're pulling.
And that's in this particular period of time when you deployed a certain version of the app.
Exactly.
Ran the test.
The load test.
Exactly. Within 12 minutes, you saw that 20 million user data objects were pulled in, filling up your memory. Yeah.
Exactly. Right. Really, really, really
very powerful.
Very powerful information. Now, and let's say I want to see exactly this select statement, right? Where is it coming from? Right? Service factors, and this information we showed in episode 1. Remember the diagnosis. So this is why the webinar everything is tied together, right? So now let's figure out, hey, where is this select coming from? This is the classic, the Nginx, right? I have here 400 requests. From here, we go back to show the request count, right? And just notice the filter. We have a change of filters that goes through the service all the way, selecting the SQL that we have, right? And now we're interested to show the test step, right? Attribute, and which step was it from my load test, right? And there we have the login.
So that means you identified the SQL statement. Then you said, who is calling that statement? You saw the backtrace.
We identified the memory growing, the API, the process. From the process, the objects, it's coming from the database. From the database, the SQL, the amount, we made a calculation to see how many data is being fetched from the database, right? And the transaction. And from here, we can just follow and see the IP or the user. This is a load test, but the same applies if you have a production use case and you have users on the UI, you can see which user, even with the session replay, to see where did he click. Wow. Very, very important. Diagnostics.
Can you also show a PurePath from here?
Yeah, sure. Just from here. Like directly show me the PurePaths.
So that means, and this is for folks that are, there's a big hype around distributed tracing. We've been doing this as part of our PurePath technology for the last 15, 16 years. So this is the automated distributed trace. We call it PurePath, from top to bottom, from the Nginx via the Apache, and in Tomcat.
Exactly.
All the metadata.
You can see in every endpoint, look at the amount of information we get automatically. The metadata, where is it coming from? Here's the test information. Then it's coming from Apache, Tomcat, the select statements, right? All that information coming really, really.
Very nice.
The SQLs, the update, and even if I click here, the code information for that specific part of the stack call, right? So really, really a lot of information. So, okay, that's use case number 1. Right, so this we did. So here now we have Jackie Chan, and we posted in LinkedIn where head is going to explode. At least mine is exploding every time we get this amount of data. So just a recap. With just a simple chart, right? We could click and see a lot of information. This is just information that the one agent is getting automatically for you all the time, whether it's test environment, developer environment, production environment, is getting this amount of information for you, right? So really, really a lot of information. So Captain Performance again here showing, hey, seeing is believing is way than just more metrics, right? Because I know metrics is a hype and traces, but important is to understand the whole, we call it the smartscape, the entity model, where in which process is which trace running, impacting which user through which memory. So everything is tied together, right? So very important. Okay, so now, okay, this is just information about the other load test about the Derby database. And we see that because of the Derby database is Java-based, right? It's just the amount of commits that we have. It's out of the scope, and also RUM is out of the scope in this webinar. maybe on the next one, we're gonna add some run use cases. Okay, now let's analyze CPU analysis. Very important also for cutting cost, cloud cost. If you want to, because normally the cloud providers are gonna charge you for the amount of CPU or memory. So now we're seeing how to optimize memory or optimize CPU, right? So which release is the most CPU intensive, which service and which methods? Can we explain why? Right, so I go back to the dashboard here, right? So we have something in the diagnostic tools that is called CPU analysis. What this is doing is the one agent is profiling the CPU of all your processes the whole time. Really, really cool feature because middleware can go sometimes crazy doing a deployment or having some issues that is independent of your application sometimes, right? And the one agent is always checking, hey, what is the CPU running here? So since we have an environment with 6 deployments in 6 hours, so I just run here the last 6 hours, and it's very easy to see, hey, at this point of time, at 3 p.m., we have a high CPU increase of this process group. A process group is a cluster of processes. So if you have a Kubernetes cluster, let's say we have 50 pods of the same application, they're gonna be here. And then we can start splitting by instance, right? So we see that the EC2 backend is getting really big at that time. So when I click on the process, now here it changes, have you seen that? And I can split even by services. So the services inside this process, right? Or the code departments inside my process. And I will see that the journey service is responsible for a lot of CPU on this time, right? And we can even zoom in and say, hey, apply. I want to analyze this in more detail. And we see here the CPU, right? So from here, I click on the loop and I will go into the method hotspots because we don't only see the increase in CPU, but also the timings is only CPU. We have disk, locking, network. We're filtering by the instance, as we can see here. And we see the threads and the methods responsible for the CPU. So I can either follow the stack trace or click on the hotspots. And in the hotspots, Dynatrace is letting me know, hey, Sergio, you know, calculate section index is something you need to take a look at, right? And like, okay, I don't know this method, but who's calling calculate section index? Well, it looks like it's calling itself. So it is like some sort of loop, right? So we continue following the stack trace and then you see, hey, and this is called by the section in loop. And then by the check destination, and check destination is called like 5 times more for find journeys and 1 time from find locations. And I don't know if you remember from episode 3, we saw the service flow calling exactly 1 and 4. We can see here the relation, right, of the methods in the services calling this. So now we're analyzing the same problem from a different perspective without comparing releases. Right, and from here we can open the source code and show what we showed in episode 3, the source code and implementation of the loop that is making the CPU increase. Right? Very, very powerful feature. Right? So, and all the steps again, they're going to be on the Codelab, so you can follow this and see it for yourself.
By the way, people keep asking about your dashboards and if they can use it. So. Yes, the dashboards are all on the GitHub repository. I just put the link again into the chat for everyone to see. There's a Monaco, which stands for monitoring as code.
Yes.
It's directory with all the configurations, including the dashboards. That means you can just run those dashboards. You can
exactly. By the way, in episode 2, we created the 2 machines needed for the whole CI/CD pipeline in 5 minutes. Mm-hmm. Yeah, like just copy and paste your credentials and run the shell script, and that's it. And we run Monaco as well from the other machine. So everything was deployed. And in episode 3, we did that again. Mm-hmm. You can break the dashboard, run Monaco, and update it automatically.
Yeah. And also a link here to Monaco. Monaco itself is the tool that has been developed in-house by our team that is managing the monitoring of all of our Dynatrace environments in the cloud. Mm-hmm. Meaning, we are running hundreds and thousands of clusters and they're all self-monitored, and they're using this tool to automatically configure the monitoring, the dashboarding, the management zones, the tagging. And it's now open source, maintained by our teams that use it internally. And it's a great use case to set up all this environment.
Set up and scale. And because as one customer one time said, like, hey, installing the one agent is really easy, but try to do it for 10, 20, 50,000 hosts. Well, with Monaco, it's also easy. Yeah. Because now you can like just roll it out and you have your management zones, you have your dashboards, you have everything in GitHub. Something breaks, you have it revisioned.
Yeah. Yeah. And I will put one more link in there. I did a performance clinic with Christoph on monitoring as code.
Yes.
So you can see it in action too. Perfect.
So now let's continue digging with the next course. So great, we see the impact of the CPU and its cycles. We saw the source code, but from our analysis, can we find out the HTTP code or the 95% of the response time, right? So, and we have seen this before. So we click here on the top, right? I can click here in the service backtrace. And you know this feature, we have used it a lot. Mm-hmm. So from the journey service, we do a backtrace and we're interested here from the Nginx. Why in the Nginx? We just saw in the PurePath all these different metadata, right? So if I filter by the Nginx, I'm having that metadata in the dashboard. So I'm also interested in the response time from here, from the Nginx, right? So from here, then I click in top web request. Now I have this multi-dimensional analysis of the traces calling the journey service, right? And then I can even say, find journeys. Remember the method that we were looking at? So now we're gonna filter by that method inside the journey service. So, hey, Dynatrace, show me the transactions calling that method, right? I click and there we have it. There, apply. Yeah. There it is. Let me just.
I think you already had the filter.
I had it already, right?
Yeah, that's it. Yeah, you had it already because you were. Yeah, the filter is already applied.
It's already applied. Exactly. Yeah. So, okay, now that we have it and we're interested in the HTTP code, right? So, there we have it. Right. Status, the code we have there 200, and we can put here like a placeholder. Let's do something like this. And add the response time, not the request count, but let's put the response time and not the average, because we have seen that the average is sometimes not really good. Better will be like the 95 percentile, right? So, and we can see 500 requests with a 95 percentile of 14.3 seconds, that's right? Cool. Calling defined journeys. Yeah. Really, really cool, right? So, okay. And now let's analyze threats. The use case is a threat analysis. So we want to find the release that has a blocking threat issue. And this question especially came on episode 3. And I said, hey, wait, because we have exactly this use case for episode 4, right? So threat issues are very, very tough to find, right? If you don't have Dynatrace. So let's find blocking threat issues, okay? So, okay, showing the slides. Dynatrace PurePath contains detailed information of the threat state, CPU, log, wait, or IO. So all the transactions running through your system, Dynatrace is not only capturing them, but capturing as well how much CPU, locking time, wait time, or IO time is spent on those transactions. right? Even the thread ID, that information has been captured automatically. So finding the logs and these transactions is very easy, just to make a dashboard and show like, hey, Dynatrace, show me the CPU wait IO time of all my services, of all my transactions in my environment, right? And we can even filter applications with tagging or management zones. So imagine you have huge environments and you can plot all of them and show just staging, prod, bank A, bank C, right? All that information really easy. So again, we come back to our dashboard. On purpose, I put this dashlet in the other one. So in here on the top right, you have this performance overview, right? And in the performance overview, it is a dashboard made for getting the overview of the health of your environment. As you can see, the time is today. We're showing the whole day. So you see the day of your applications, the request count with 95%, failed transactions, database calls, and on the right and the left are the max time versus the more chatty applications or services, right? Which services are called more the database. And in here we have one very powerful, the colors are not very pretty, for my opinion, but he's very, very powerful.
Very, come on.
Yeah.
No, don't be shy to talk about color. My color skills are definitely not as good as yours. So in here, and we can see the pattern. Why? Because we have this Alfred, call it like we're triggering the problems every hour, right? Like we're deploying every hour. And we see at 6, 12, 6, we have this sync issue, right? So actually, let's put just the last 6 hours. So we have the 6 releases. With the colors, we can see, hey, in here we have a lot of transactions with CPU time. But here, the red ones, this is locking time, right? 10.3 minutes of locking time. This is a great dashboard because it's just so simple to show you really if during certain periods.
And I can say, for example, here we have a bank job, which is just one Docker container running whatever is running. Maybe we're going to use it for another webisode. If I filter by it, I'm filtering by that bank job.
Yeah.
Really, really great information.
Yeah.
And now it's like, hey, show me easy trouble. Boom.
Yeah.
Right. And this can be one host, one container, or 1,000 containers.
Yeah.
So in the log time, here, we can add the service, right? So we see, if I scroll down, services not splitted, hey, the journey service has 1.3 hours of logging time. That's it. That means that the amount of transactions run through this time sums of 1.3 hours just for log time.
Yeah.
Just being locked, blocking themselves is the amount of time our users have been waiting, or well, load test in this case, right? So we click in there, right? And then we can see, for example, the service flow, right? Or the backtrace. Because here's the journey service, but let's say I'm interested in the backtrace. So I'm keeping the filter and I'm understanding, okay, where these transactions come from. We already find out the service, right? And we see they're coming from this request and also from the web server to the Nginx, right? And from here again, I go back and then I filter, keeping the change of filter, something we learned on episode 1, and see exactly how the flow of the transactions run, right? All the way to the easy trouble service. And important as well, we see the amount of them, the response time, the request. We can show here the throughput, right? And also on the top right here, we have the infrastructure. So whatever we click, let's say this journey service, we see the stack, right? Through which instance on the right side are these transactions running, right? So going back to the use case, we can see here the transactions. Oh, by the way, I wanted to show there, the method hotspots, sorry. Because let's see the method, right? So there are different ways to analyze. I can click here the method hotspots because we were actually interested in where is the synchronization issue happening, right? So, and Dynatrace is letting us know automatically, hey, at 12, you have here a lot of locking time, right? And we can actually here just put something very nice. I can put 12 to 1, right? I should have put 12 to 13. 13. We get more data, right? Like we're cleaning to understand, okay, exactly our traces here and seeing if I'm interested in just the locking, automatically we can filter make it easier, right? See, hey, define journeys, execute plugin to execute, right?
So where is all of the locking time coming from? Exactly that time frame.
Exactly. And even better, so if I remove the selection of the locking, I can see, and we saw this problem, we analyzed it from the other perspective in episode 3, where we saw, let me just show the jump. I find it really, no, where we have it, the jump from the locking from one method to the other. So here, find journeys, this is will impacted, not impacted, right? We have the do execute, and we saw this, we decompiled the class. So check episode 3, it's really easy. We just click here on the right side, source code, and we get the class from the agent.
Can you do me a favor? Can you click on hotspots on the top? Like it is like the view, if you scroll up, like instead of call hierarchy, hotspots.
Yeah, it's gonna do it for us.
Exactly, that's it. It's the method,
Yeah.
That's the beauty.
But this is for the non-believers. So
I still hope that at some point our product management will kind of, I think the hotspot for me is more interesting and more useful from the default view.
Definitely.
I think we should
to make it a default. Yeah. Or even put it in the root cause analysis.
Something like this.
Hey, this method.
Exactly.
Right. Yeah.
By the way, folks, we have about 15 minutes left. So if you have questions, make sure to use the Q&A feature. Remember, again, you have full access to this Dynatrace tenant. The information you'll find in the chat, how to log in.
Exactly. And now I have another use case. Some of you might be asking, hey, what about if my middleware application has an internal blocking issue? Because what we were showing are exposed transactions, are transactions for the user. So normally Dynatrace automatically expose every web request, but it might be a batch job internally or from the application server. What if there is a blocking issue there? Well, don't worry, Dynatrace also get this information automatically, right? So if I go to the diagnostic tools in the CPU, right? Here we have the CPU analysis, right? So we have the business backend. Let's say we're interested, like, hey, what is in our business backend running, right? So on the right side, here we have threads. So we showed the memory allocation, the memory profiling. What about the threads, right? So if I click in threads, we go to the thread analysis, right? So we get the thread groups. We can see here the thread groups, right? We see the CPU time and the thread states, right? So at this chart, let me just put it from, we had, I don't know, let's put 11 to 13. So now I want you to pay attention to this. In the type, we have background and service. Service are all the traces with this really high detail information. Background is the transactions that normally are part of your application that we're not exposing. We can always expose them, but we're not exposing them, right? Even though we're not exposing them, Dynatrace is keeping information of that. So I click in the background and say, hey, do we have any issues here? Well, not really. We see a network increase of background information, right? But what about the service information? Meaning the transaction. And automatically we see, hey, our exposed traces, they have a problem, right? And if I click here to the thread group, I even see the thread IDs, right? And these thread IDs, I can click here from the method hotspots, and it will bring me from the thread groups and thread IDs to the methods and transactions that we were analyzing. Really cool, huh?
Yeah.
I mean, well,
that's amazing.
Yeah.
The guys that are building, guys and girls that are building this are all out there somewhere.
Yeah.
Sitting here in the office.
Flying with capes.
Yeah.
So, yeah. And, well, I will continue. We have time. Another excursus is to show, but I think I can leave this for the guys to test it out.
Yeah. And the thing is, we always need more for other episodes too, right? We can also recap this.
Exactly. So it's just from the methods that we were, just click on the backtrace, and actually I have here the steps, right? We click on the backtrace, we can show the service flow, we can analyze which requests were there, and there were 500 requests with a 95 percentile of 21.8 seconds, right? So imagine the impact of that logs to the application, right? So that means that this search transaction, the random search, is taking 21 seconds to complete. So if we make this release to production and we have users, concurrent users, they will be waiting 20 seconds for a search.
Yeah.
So very, very, very important feature, right? And even showing the SQLs, right, by this random search. So when we show here the service flow, on the right side, you click on View Database Statements, and you see the database statements as we were on the last problem, that you can see the request count, fetch count, and in this use case, we're seeing the amount of select statements being triggered at the amount, right? So this thread analysis has to do with the amount of statements also being executed. And with this, thank you very much. Concluding episode 4 of Why Devs Love Dynatrace.
Nice, but I don't let you off the hook that fast, okay? So I know you've shown a couple of cool things, a lot of cool things actually. I want to show quickly one thing, and I know you said we probably need a whole new episode for this anyway, but I know we have a lot of people out there that love distributed tracing, that love PurePaths. And yeah, do me a favor, click on it. This is something, Diagnostic Tools. So first of all, this is the place where you get to most of the things you showed today, CPU analysis, memory dumps, and so on. But the new view, thank you. The new view that was just introduced is PurePaths, right?
Yes.
So you want to quickly click on it?
We're getting more and more diagnostic features for all of you developers out there. Give us also feedback. We appreciate the feedback because all this development is synchronized with our customers' want, with what they need. So yeah, and if you have been with Dynatrace already for a while, you see that every second week we're making a release and we're giving more stability, more power, more visibility to your applications. So in this, PurePath is a way to find all the distributed traces in your environment, right? And you have the way to slice and dice and say like, hey, show me all the transactions of a Kubernetes namespace or a Kubernetes pod, or I don't know, let's say we have easy travel, right? So let's just show for the backend easy travel, right? And boom, we have here their traces from the backend, and we can start continuous trace. And in each trace, we have also the metadata that help us get an overview. And from here, then just say, hey, show me the PurePath, the backtrace, response time hotspot, right?
Yeah, you can also do me one more favor, remove that filter now. And then let's say you're interested in slow transactions that are HTTP posts, for instance, right?
So let's just see, here we have response code, let's say...
Or HTTP method post, let's say, right, give me all the HTTP
Give me all the post, and give me all, I don't know, slower ones.
Yeah. So
or even with CPU time,
yeah, exactly.
log time limit. Log time. Do we have log time with more than, I don't know, 20 milliseconds in post request?
Yeah.
Right. And you can start slicing and dicing. Do you have requests that are slower than 5 seconds, 10 seconds? I don't have 20 milliseconds here because they're like post. But let's say, for example, which by the way, in the dashboard, I'm just gonna change really quick, right? Here, you have predefined filters, but these are for the requests, but we can adapt them for the PurePaths. Because everything where you click in Dynatrace is shareable. So when you find a problem, you can really easily share it with your colleagues and say, hey, Peter, hey, John, remember what you did? Here is the impact, right? Whether it's good or bad.
So I just wanted to show, I mean, we'll do probably an episode on PurePaths distributed tracing. We've always had them. I think we now just make them a little bit more front and center, especially as we want to be, make it easier, especially for developers and engineers to get to their distributed traces.
Exactly. And also especially because, as you know, OpenTelemetry is gaining more and more attention, right? So we can even find out, we integrate with OpenTelemetry really easy. So you can find them, the trace ID, and say like, hey, I'm really interested in the trace ID. But it's like we were showing episode 1. It's even easier with developer name, like, hey, I'm Peter, so show me all my Peter requests, right? Or Sergio requests.
Very good. Hey, there were, as I said earlier, some questions on the dashboards that you built. Can you just quickly go back to the dashboard?
Yeah. So there are 2 dashboards. One we started using in episode 1 and the other in episode 2, right? So let me just go to the other dashboard. By the way, when you run Monaco, there are some variables, and the variables are just of your host, where Easy Travel is running, because this is a variable that we replace. So if I click here in Classic, I'm opening Easy Travel in the Classic mode. So we're just replacing the variable, so your dashboard is linking the systems, right? We have also kept that in a box, right? Like running all the quality gates for you, right? And we have Jenkins deployed in there, so you can see and enhance it. So you can use it as a template. If you say, hey, I have Jenkins and I want to have all this, but not for Easy Travel, but for my application, it's really easy to copy from here and just have it applied into your application.
Yeah, and I think this also shows the power of Monaco, because what I've seen with customers, you typically have like a couple of dashboards that you use per application when you onboard a new app. So you want to create the new dashboards, but then customize it, like, with a link to the deployment, with a link, I don't know, to their Jira system, with whatever they have, right? But this is really powerful.
Exactly, and I'm gonna show exactly where everything is stored. So we have here, for example, episode 1, and in Monaco, right? Here we have a bit of information, what are we deploying, the link to download Monaco, the binary, right? And also here the repository, right? So in this repository, I'm gonna just show exactly where the dashboards are. So here in dev.log, all the configuration we have is episode 1 and 2, because 3 and 4 were just hands-on on what we had in 1 and 2, right? So if I go to episode 2 and I wanna see the dashboard in episode 2, here it is, load test overview. It's just this JSON file, right? So that's the dashboard. And in episode 1, the other performance overview is here, right? So all this configuration is stored in Monaco and is revision. So if I change something here, I run Monaco again.
Yeah, that's it. Yeah, it's really nice. All right. Hey, with this, it is almost the top of the hour. It is beer o'clock, as they say here. And but I still want to give people maybe 30 seconds more to ask any final questions. I know it's the summer months. You probably have something else also on your mind on the 8th of July. But thanks for the folks that have joined us live. Thanks for everyone that has been giving us, especially you, some amazing feedback that we've received through email and some personal shout outs. I want to personally thank you, Sergio, because this was really awesome.
Thank you it's a pleasure to be here, for the opportunity to be here.
Yeah, the thing is, I remember the days when I kind of did a lot of these things on AppMon, educated people on the PurePath and doing the diagnostics. now there's the product is so big, and I'm also shifting focus a little bit towards cloud automation and Captain. So it's awesome for me to learn from somebody like you how to truly, use the product in so many different ways.
Yeah. Thank you.
There you go. All right. With this, I want to say thanks again, and have a great summer or winter if you live in the other hemisphere. But yeah, hopefully, stay healthy, stay safe. Wish you all the best, and we'll see you soon. I'm sure we will be back with Why Devs Love Dynatrace with more episodes.
More to come.
More to come. All right.
Cheers.
Bye.
Bye.